Okay guys, here is a mock-up, or a, if you like, a fit of the completed front panel assembly using the existing glass dial. And as you can see, the station names in the center here are all pretty much eroded and vanished, so I'm having a replacement professionally made. So I made up 4 rubber supports for the glass, and I just used a conventional eraser, lead pencil eraser, and I cut 3 T-shaped ones so the little tang of the T would go down the hole. And yeah, I know it's white, but as you can see, when you have the clips on, you can't really see, and it's not visible when it's assembled anyway. The interesting thing was that really all 4 of these rubber pieces have to be exactly the same height, otherwise you have the glass is stressed, and when you clamp it down there's a risk you could break it. So yeah, I spent a little while making sure that was okay. And so the other thing I wanted to quickly check is, since this color is slightly different than the original, if it would make any difference to the legibility of the station names. But I think we're good. I think it's even the ones along the bottom here, I can see them very clearly, and any of the lighter color ones are just fine. So yeah, I'd say we're good. I'd say this sub-assembly is basically done at this point. The only other thing I have to consider is the original has a piece of resistive wire going across, shunting the dial lights, the dial bulbs, and so in the first one I replaced it with a couple of resistors which just sort of hang here on the top. And so I may look at something a little bit more elegant. I may be able to sight them and mount them on the back of this panel or somewhere else. So I'll play around with that and see how we go. So yes, there we are. This is the front panel, pretty much done, just waiting for the new glass dials to arrive, which will probably take a couple of weeks yet before they arrive. Because I guess, as you folks know, the decal process doesn't work when you have white ink, because you cannot print this, inkjets, or most laser printers can't print white, and so you kind of need to get it done professionally. Right, that's another step forward. Right, I've removed the whole speaker and output transformer assembly because it's just going to get in the way from here on out, and it's very heavy, and I'm totally paranoid that I'll damage it. So just a couple of final things on the chassis itself. So I refitted the original serial number plate. This was originally riveted on with 2 very, very small rivets, which hadn't been peened over so much on the other end as simply bent over. And I thought, okay, I'm never going to find rivets like that. However, what I did have was these small panel pins, and so I fitted a couple of those. And now that I have a big hefty soldering iron, I was able to just put a couple of big blobs of solder on the other end, and job done. So there we go. I think. So it's at the stage now where I can clear coat it, and then start thinking about rebuilding electronics. Okay, I think I'm on to what must be the final mechanical task here on this particular chassis. So, which is to make the metal bracket that will hold this end of the chassis in the cabinet. Now, when I was doing the other one, this bracket being here, while I was wiring up things like this valve underneath, was a bit of a pain. So what I'm going to do is, I'm going to make it all up, but I'm not going to fit it until after the whole thing is wired up, and then I'll just snap rivet it in here. So I'm just going to, if you like, fix this in temporarily with a nut and bolt here. Then I'm going to put the thing in the cabinet, mark the position of the hole, from through the hole in the cab. Fix a captive nut on here, and then cut it to length, and then we're good. Then I'll just put it away until much later in the project. So with the chassis temporarily fitted in, I can locate the hole in the back. Like so. At least that way it should be pretty accurately located. Okay, having lined up the case and found the position of the hole, you can see I wasn't exactly spot on. I actually lined up the center line of my bracket here with where the spot weld was on the chassis for the original. Looks like the spot weld was not on center anyway. So hole is slightly off center, but hey, it won't matter once everything is put together. The captive nut system that I'm using, I don't know if you guys have seen this, but it's basically kind of like a pop rivet. You have a special nut which is threaded on the inside and then has a section which can collapse, and so you essentially have a tool which screws into the nut. You pop it through, and then you basically pull this shaft back, which expands the a collar on the other side of the plate, and you have a captive nut. Hopefully it'll be obvious when I've done it. So basically this is the guy, which is kind of like the modified pop riveter. We stick it through, we screw it on here, and then it catches. It's held here, and I pop it in to the plate like so, and then you squeeze like so, and I don't know if you can see it, but then that expands the shoulder on the other side of the nut, and then I just unscrew the shaft that used to pull it through, and we end up with a bracket with a nice captive nut on the end, which, if I haven't lost concentration along the way, is 4mm. We're good. We're good. Okay, so I'm just going to put this away. I won't fit this onto the chassis until much later on in the project, because, as I say, this bracket just sort of gets in the way of the wiring when you're trying to wire up the valve which sits underneath this. So I think that is pretty much the last mechanical task done. So from here we go to start on electronic stuff, and I guess the first thing I want to really check up on is whether or not the IF transformers resonate anywhere close to where they should, because I can't do an alignment on my set because the slugs are all glued. So we'll have a look at those before going any further. Right, I've masked off the chassis in preparation for a clear coat. And boy, that took way longer than I was planning. Couple of little complications as well. Some of the earthing braid that was on the front here, and there's another piece goes on here to connect to the tuning condenser. With all this sort of moving them around back and forth while I was doing all the other stuff, they basically came undone. They just sort of broke. Right, degrease and then paint. Right, degreased, ready for a bit of paint. Okay, chassis clear coated. In my experience, this clear coat sets in a couple of hours, but it takes about a week before it's really hard. So I'll have to try not to scratch it or mess it around until it's fully set. So I guess I should do the 2 IF cans as well, since they were kind of badly rusted. So we'll give those a go. Okay, so I clear coated the cans, the IF cans as well. And here's our handy dandy tip of the day to protect the little screw threads here from getting gunged up with paint. I just put some heat shrink tubing on them and shrunk it on to protect the threads. I can just cut that off with a knife. So I think that's all my clear coating done. I was going to have a look at the tuning condenser, but at the moment that seems like a lot of trouble to mask it off accurately and then spray the bits that are left, so I might just leave that for now. Since I'm nearly coming to the end of the mechanical stuff, I've started thinking about the electronics. One of the first things I thought I'd try and sort out is whether or not this set is going to need a lining. The reason that's kind of important is the schematic for this says you can't do alignment, because once it was done at factory, all the slugs were glued into coils, and so you can't free them out. So what I thought I could do while everything is out, before they're actually refitted in the set, is take each of the tank circuits in each of the transformers and see where they resonate. And the IF frequency for this set is 470 kilohertz. So the way I've set this up is signal gen coming in one side of the tank circuit, scope going out the other, two words connected, and then check out on the scope. The reason my overhead light is not on is the angle of this scope unfortunately means the fluorescent light would be reflecting straight in the screen, and so you can't see it. So I'll do each of the 2 tank coils in each of the transformers, and I'll do the tank coils on each side of both transformers, and then we'll see are they okay, are they spot on, or are they so far off that I have a problem. The signal generator into one of the tank circuits, and then we'll see where it resonates the most. So if I increase the frequency, okay, I think we just passed. Okay, I'm going to call it there. And I don't know if you can see it on the camera, but this is 470 kilohertz on the frequency counter, which is exactly spot on for this particular set. So that's good news. So let's try the tank circuit on the other side, just for fun. Crank up the frequency. Oops, I have to change the scale. And there we go. I'm going to call that the maximum. And again, as you see down here, 470 kilohertz. So looking good, looking good. So let's try the other transformer. Okay, so this is the other transformer connected. I'll wind it up. Okay, we're already over to 470. 480. Okay, that looks like 486 kilohertz. Yep. So that's off. I'll just try the tank circuit on the other side. It's even further off. .498 kilohertz. Okay, so one IF transformer looks to be pretty much spot on. The other one is definitely off. I can't mess with the coils or the slugs since everything is glued, so but the only thing I can do here, I think, is first of all change the mica caps and see if that makes a difference. And then, as one of the guys on the forum suggested, I could also replace the mica caps with the trimmer caps. And that might work because I can't adjust the inductance. I can only mess with the capacitance. Okay, so we're going to have a little bit of a sidetrack while I go figure out what to do with this IF transformer. But at least one's good. Okay, this is a suspect IF transformer. You can see the flying lead going off to the grid is rather badly aged here, so we're going to have to replace that. And here are the two mica caps across the top, and there are the two coils. So at least these older ones are quite sturdily built, so a little bit easier to work on than a lot of the modern ones, which are much smaller and built on much flimsier sort of constructions. So the goal at the moment then is to replace these two with 100 puff mica caps and replace this flying lead. We can get that underway. Okay, old caps removed. And there they are, and the two new ones that'll replace them. I'll just give this a tidy up and re-tag the new ones in, and then test. Okay, cleaned up a little bit, two new mica caps fitted, and a replacement lead for the grid cap. And I got some nice period fabric covered cable for the job. I've left the tail a little bit long at the moment because originally the lead here was meant to just reach outside the housing onto a very tall valve, but I've got the metal, the black ones, which are shorter, so I need a slightly longer tail on here so that it's not being pulled in any way. Right, let's get it back into the rig and see if this thing resonates any closer to where we'd like. Well, not much luck. It's helped just a little bit, but not a great deal, because there it is on 470 kilohertz. And this was at 490 or something before. And now it goes to 488. And the other side was at 486, and I think now it's down to 478. So it's helped a little bit, but not enough. So I think I may just do a little bit of trial and error with some of these caps and just tag them on and see if I can find a fixed value that'll help. Let's see how that goes. So after lots of messing around with different values of mica caps, I think this is as close as I can get it without having to go to trimmer caps. So here it's on one of the tank circuits is at 468. As close as I'm going to get it. And I go on the other tank circuit on the other side. It's almost exactly the same. Now I had to put 110 puff cap on this one, on one side, but 110 was too much on the other side, so I ended up with 105 in parallel to give me 105. And as I say, they both at least now seem to resonate at very close to the same frequency, albeit it's not quite the one I'd like it to be, but it's close. But then there are so many variables out here on the bench, so if you just touch anything, you change the capacitance and everything alters. So I think we're going to call that done at this stage, and we'll move on, and then we'll wait and see what the reception is like on the set and selectivity and everything else, and let me see whether we need to come back and revisit this or not.